Hi, everybody. Welcome to 3.2. Today we'll be talking about the angles of triangles. For our learning target today, it is I can find the measures of interior and exterior angles of triangles. And that's the first thing we'll talk about here in our vocabulary. It says the angles inside a polygon are called interior angles. That makes sense. So in this case here, these red angles that are shaded, there are three angles in a triangle. When the sides of the polygon are extended, there are other angles that are formed. And the angles outside the polygon that are adjacent, or another word for adjacent is next to the interior angles, are called exterior angles. So if you look at this model over here, you'll see that this is our interior angle on the inside, and the two angles that are next to that or adjacent to that are considered our exterior angles. So there are two exterior angles for each interior angle. Right? This is the interior angle. Here are its two exterior angles when you extend the lines of the triangle. Right? That's why they got the arrows here. Notice that this angle right here is not counted as an exterior angle. We count that as a vertical angle. So those angles are not included in the exterior angle measurements. It's the two that are adjacent or right next to the interior angle. For our key idea today, what I want you to take away, and some of you might already know this, but the interior angle measures, so the angles on the inside of a triangle have a sum, or they add up to 180 degrees. And that's true for all triangles. That's a base rule for all triangles, that their interior angles, so in this case, X and Y and Z, when you add them together, will always give you 180 degrees. So let's see that in action. Using the interior angle measures, find the value of X. So for letter A here, I know that this angle is 32 degrees, plus this other angle I know is 48, plus this last angle, X, should give me a total of 180 degrees. Okay, I will simplify. My two like terms I can add here, 32 and 48 would give me 80, plus X is equal to 180. So 80 plus what number gives us 180? Or you could think about it as, to isolate X, I would subtract 80 on both sides. And X would give you 100 degrees. Okay, moving on to letter B, we'll do that in a similar fashion, except now we have a couple more unknowns. So my first angle that I'm going to account for here, it gives me this little red box. Well, remember that that's a 90 degree or a right angle. So I can put 90 plus the top angle here is X plus 28 plus the bottom right angle here is X. When I add those three angles together, they should total 180 degrees. And some of you might be wondering, why are the parentheses here? Again, that's just a group. That's just to show and to kind of make this problem look a little neater. Is essentially all that those grouping or parentheses are for. All right, let's simplify. I've got a couple of like terms on the left-hand side of my equation. Like terms that I can add x and x. X plus x is 2x. Plus, I also have 90 plus 28, which would give me 118 equals 180 degrees. And now I have this down to a two-step equation. I'm trying to isolate x, so first I would undo my addition. So I'd subtract 118 from both sides. I'd be left with 2x is equal to 62 And then I would end by dividing by 2 on each side. So x is equal to 31 degrees. Go ahead and pause the video next to try the 2 on your own. All right. For the first one here, you should have 81 plus 25 plus what other number gives you 180 degrees? You should arrive at 74 degrees. And that makes sense. Just looking at this angle, we don't always know that these are accurate, right? We're not putting a compass to these. We're not saying that this has to be exactly 71 degrees, like if you were to use a compass. But just kind of eyeballing it, if this dotted line represents 90 degrees, you could see that x here is less than 90 degrees. And it's pretty close. So 74 kind of makes sense there. And I'm not saying that that's, if you took a compass to this angle that it would be exactly, but kind of eyeballing it, it looks to be accurate and it makes sense. For number 2, you should have x, I'll work this one out, plus x minus 35 plus 43 is equal to 180 degrees. Like terms, I have x plus x, so I'd have 2x again. And then I have negative 35 plus 43. So negative 35 plus 43 would give me positive 8 equals 180. I'd subtract 8 on each side. So I'd be left with 2x is equal to 172. And then in my last step, I will divide by 2 on both sides. So 172 divided by 2 should give you 86 degrees. If you have questions on either of those, please come let me know. All right, those are the rules for the interior angles of a triangle, or the inside angles. Next, we're going to look at the rules for exterior angle measures of a triangle. Okay, so it says the measure of an exterior angle, or the angle on the outside of a triangle, is equal to the sum of the measures of the two non-adjacent interior angles. Non-adjacent. So if adjacent means next to, that means that this is the adjacent angle to angle Z. Right, this is the angle that's next to my exterior angle. We actually don't worry about this angle. And what we're concerned with, or what we're using, is the two non-adjacent, so the two angles that are not next to the exterior angle. And it's the sum of those two. So if you add y and x together, that will give you z. So as they're showing here with the algebra, z is equal to x plus y. Okay, let's go over an example with that. It says find the measure of the exterior angle. Right? Well, x is equal to the two non-adjacent sides added together. Well, this is the adjacent side. This is the angle that's next to x. We're not concerned with that. The two non-adjacent are 36 and 72. And we just have to add the two, the sum of the measures of the two non-adjacent. So really all you have to do for letter A is you have to add 36 and 72, and you should get 108 degrees. Okay. Letter B is similar to that, except now we just have a little bit more algebra to do. So here's our exterior angle, 2A, and that's equal to the sum of the two non-adjacent. So these are the two non-adjacent interior angles. So 80 plus this other angle of A minus 5. Okay, so now we need to do a little bit of algebra. On the right-hand side, I've got like terms. I have 80 minus 5. So that would give me 2a is equal to 80 minus 5 would be 75. And I still have this plus a I'm going to bring down in my equation. And now I have variables on both sides. So I'm going to move this a to the other side. So I have all my variables on one side and constants on the other, if you remember that from a couple chapters ago. So to move this a, I'm going to subtract a on both sides. Because a minus a is 0, which is what I wanted to do. I wanted to move all my variables to the other side. And 2a minus 1a, well, that's just a, and I'm left with 75. So I have a is solved for. Now, be careful. You solve for your variable here, but what do they ask for? They ask for the measure of the exterior angle. And in this case, the exterior angle is 2 times a. So 2 times 75, the exterior angle would equal 2 times 75 is 150 degrees. Okay, so be careful and make sure you read what they're asking for. In this case, it was just x, so whatever we found for x was our answer. Alrighty, moving on to the real life example, kind of a cool one that talks about this area just southeast of Florida known as the Bermuda Triangle. Maybe you've heard of it before. It says an airplane leaves from Miami and travels around the Bermuda Triangle. What is the value of x? So x is right here. Boy, it would feel nice to go to the Caribbean right now. And if you know anything about the Bermuda Triangle, it's kind of like this mysterious place that people have tried to figure out why, but for some reason, a lot of ships or planes, they say, go missing. There's a lot of crazy theories or conspiracy theories out there, maybe that you're interested in that you should look up sometime, but kind of this weird triangle that is between Bermuda, Puerto Rico, and Florida. So if you want, check that out. Anyways, back to the math. We're trying to find the value of x here. Well, first off, notice that we're dealing with interior angles. So we should be thinking about the rule of all of our interior angles adding up to 180 degrees. So let's do that. My first angle is x plus another angle is 2x minus 44.8 plus my last angle is 62.8. And when I add those together, they should sum to 180 degrees. Okay, now I will add my like terms on the left-hand side. So x plus 2x would give me 3x. And then I have negative 44.8 plus 62.8. And if I were to rewrite that with this term first, it'd be the same thing as 62.8 minus 44.8. 8 minus 8 is 0, decimal straight down. I'd have to borrow. 12 minus 4 is 8, and 5 minus 4 is 1. So that just gives me 18. So 3x plus 18 is equal to 180 degrees. Subtract 18 on both sides, getting rid of our constant first. We'll be left with 3x is equal to 162. And finish by dividing by 3 on both sides. 3 goes into 16 5 times, which is 15. Okay, so it's got to be C then, 54 degrees for my x, my value of x. Alrighty, please pause the video here for the last on your own problems. right, for number 3 here, all you needed to do was add these two together, so you should get y is equal to 70 degrees. For number 4, just for time's sake, I'm not going to work it out. You should arrive at 140 degrees. If you don't know quite how to do that, let me know, and I'll be glad to help you work it out if you didn't get that answer. And then lastly, just change up a little bit some of the numbers from example 3. And if you did that correctly, the value of x, you should get 54.3 degrees. Okay. And that does it for 3.2 and angles of triangles. Let me know if you have more questions. Thanks for checking this out. I'll see you guys later.